Hello, welcome to this video. In the last class, we have derived work required in a single stage compressor without clearance volume. Now, let us simplify the same equation for single stage compressor with clearance volume. Now, remember this was the diagram without clearance volume. I have just renamed it. In place of 4 and 1, I have renamed it as B and A. Now, with clearance volume means piston does not go to the top dead center. So, we will have somewhere here it is stopped. So, point 3 is somewhere, okay, and then it is brought back to its initial state by, let us say, a polytropic process. So, then we will have this as PV power n is equal to constant. So, this is again PV power n is equal to constant. Now, 3 to 4. Now, remember, if you forget about this 3 to 4, it is still the without clearance volume, that is 1, 2, 3 AB, right. So, with clearance volume it is now 3 to 4. Now, we can say work required will be we have already derived. I mean, if you forget about this 3 to 4, it will be like work 1 to A B 1. Now, this is the same expression without clearance volume, remember. So, if you forget 3 to 4, if you go back to the same expression, 1 to A B 1 will be the same expression. Now, this should be the net work, I mean this total work. Let us subtract this small part here. Now, how do we subtract that part? That part can be subtracted from this, like if we subtract 1A to 1, if we subtract work in 4, 3, A, B and again back to 4. If you subtract this, then that will be our actual work from here to here. So, all I am doing is we know the expression for this. This is our 1, 2 and AB. Okay, this is our total work without clearance volume. Now, we are talking about this part and we have named as 3 and 4. Now, in this whole part, if we subtract this part, we will get the work with this clearance volume, all right. So, I am subtracting the same thing here. Okay. Now, what is this expression which we have already got? We have already got the expression for this as n by n minus 1 P1 V1, that is P initial V initial, into Rp power n minus 1 by n minus 1. This is the expression we have got for without clearance volume. Now, if you look at this part, this is also the same diagram without clearance volume. So, for this process, the initial pressure can be taken as, so n by n minus 1. Similarly, P4 V4, all right, into the same pressure ratio Rp power n minus 1 by n minus 1. Now, we can take n by n minus 1 and P1 and Rp power n minus 1 by n minus 1 as common from here, and then we will have P1 V1 minus P4 V4. Okay. Now, n by n minus 1, I will Rp power n minus 1 by n minus 1 into, I will take P1 common here because P1 is equal to P4. So, I can take P1 as common, therefore, we will remain with V1 minus V4. Now, if you look at this V1 minus V4, this is actually effective swept volume, we call it as. This portion We will call it as effective swept volume. Effective swept volume is equal to V1 minus V4. That is the actual volume of air which is drawn in, right. So, because V1 minus V4 is equal to effective swept volume, we will write it as work required with clearance volume will be n by n minus 1 Rp power n minus 1 by n minus 1 into P1 into VES, alright. Or I am just regrouping it so that it is easier for us to remember. P1 VES I will rewrite here, then Rp power n minus 1 by n minus 1. So, this will be our work equation for a single stage compressor with clearance volume. So, this will be our equation. Okay. In the next class, we will take multi-stage compressors. Thank you.